Hello? Oh. All right. Yo, what's up? Welcome to boot camp. All right. We can get started. Keeping some notes over here, so sometimes I'll look over my phone. Hello, everyone. Welcome. My name is Mr. Boscarino. You can call me Mr. B. Yeah, my name's Nima. I mean, yeah, my last name is Boscarino, but don't call me Mr. Boscarino. Mr. Boscarino is my father. I'm just Nima. So, I'm one of the instructors here. One of the lead instructors. I got a chair over there. That's about as much as there is to me. My background's in computer science and education. I'm telling you about myself because I didn't do the quirky fact at the beginning of the week. I like embroidery and Brooklyn Nine-Nine. That's really about as much as there is to like this situation. We'll get to see each other a whole bunch. I do a lot of lectures, do a lot of technical interviews. So yeah, we'll get to know each other. Now let's each go around and introduce yourselves. No, maybe not. There isn't a ton of time for that. But I will be lecturing today. And today's topic is particularly groundbreaking and interesting. It is, first of all, what day is it? It's week 1, day 4. Wow, week 1, day 4. You're like 4 days into the program. That's awesome. You're like almost done. No, you're not even close to being done. There's a long way. But hey, I mean, 4 days, that's awesome. You know, props to you. Congratulations. There we go. Thank you for joining me. Yeah. No, I'm very proud of you. I'm going to be even prouder of you at the end of the day because you will have finished week 1, day 4. I genuinely do want to point out, like, be very conscious of the fact that, you know, you're going through this boot camp. Not very easy. It's pretty long. It takes some time to, like, reward yourself once in a while. It can be very easy to kind of sink yourself into the whole, like it's grind time, like, yeah. And then you don't take any time for yourself. Still, you know, drink some water. Like, go for a walk. I don't know. Look at a picture of a puppy once in a while. Like, you remember feelings? Have some feelings. Just feel happy or something. Like, that's okay. Make sure to, like, have a little bit of time to yourself. And one of the things that I really want to make a point of before we get into the meat of today's lecture is, like, these topics are not easy. They're, like, not easy to sink into your head. You cannot expect yourself to just grind and have this stuff sink in. Right? Sometimes it's going to take, like, you're going to need to get up and go do something else, right? And let these thoughts coalesce and then come back, right? I want to make it very, very clear that, like, this is not the kind of thing where if you get, like, stuck on one thing, you have to, like, keep digging at that one kind of concept. Programming is made up of lots of kind of interlocking mechanisms, right? Shift your attention to other stuff, right? Ask for help, right? This is very early into the program, so y'all are, like, very keen, which is great. Continue that energy, especially of asking mentors for help, right? So I'd like to remind everyone at the beginning of, like, every week 1 lecture, there is a 15-minute, like, guideline. Right? You can use the 15-minute life hack. Right? If you are stuck on something for 15 minutes, right, then, like, straight up ask for help. Cool? Cool. All right. Some of you will not do that. That's fine. Just please ask for help. The thing that this program is kind of designed around is like a leapfrog mentality. We want to keep the ball rolling and, like, the momentum going, right? And you can get stuck in some of these concepts for a really long time, right? For example, this is it's almost infuriating to me. You're going to be learning about callbacks today. Do you know how long it took me to learn callbacks? It took me months. It took me years. I went to my first job. I didn't even know what a callback was. I figured it out on the job over the course of weeks. You're probably going to be great with callbacks by the end of this week, right? It's just incredible to me. And the only way that that really works is that every time you get stuck, you ask for help, right? Agile kind of stuff. Now, we don't know what callbacks are yet necessarily. I think there may have been a reading on them yesterday. May have. I might be wrong. We're going to be spending some time on this. But before I even do anything about today's concept, which is again, where'd you go? Which is again callbacks. I like to start off with a little bit of like a motivation, and we're going to play around with JavaScript in a little bit of like a toy setting. I'm going to have you guide me through what's going on with some of these things. First of all, let's start off with a question. What the heck is JavaScript? What is that? Java script? Java script. What is it? Yes. Cool. It is a programming language used mainly for web development. Cool. So the key thing that I want to focus on here is it is a programming language. Right? It is a programming language. What are languages used for? Languages are used for communicating. So languages are for communication, and you can communicate all kinds of stuff. I can communicate things like, "Hey, how you doing? What's up? Why don't you ever reply to my text messages?" Like those are all things that I can say and I can communicate. So those might be like questions, just inquiries. Right? I can communicate other stuff like, "Give me the money." Where is she? Right? Like just more kind of commanding things that require a response, right? And maybe even require an action. So I might give commands. Those are things that I can do with the language, and I can do that with English. And similarly, I can do that with a computer. Right? I can talk to a computer, ask it to do stuff. And that's what you're learning with programming in general, is like a particular way of communicating with someone, but that someone is a robot. Now, we're using the programming language JavaScript. JavaScript is not much unlike other programming languages, such as Python or C, or let's come up with another language, Scala, all kinds of languages, or Erlang. All these languages are designed to be able to talk to a computer and ask it to do things, right? Generally asking something to perform some actions. All these languages are slightly different, though. Some languages have slightly different syntax, right? For example, in JavaScript, you use semicolons at the end of lines. In Python, you don't. Neat. Cool, little difference. Here's another slight difference. In JavaScript, you write out the word function when you make a function. In Python, you write out def. Neat. Just another small difference. These are syntactical differences. There are also things that make a language special in the way that it sees the world. Right? So for JavaScript, and we're not going to look at the way that other languages see the world right now. You will eventually see how Ruby sees the world towards the end of the boot camp. But one of the things that makes JavaScript tick is that JavaScript sees everything as values. Right? JavaScript sees everything as a thing that you can hold and a thing that you can move around. So as I'm working on today's, through today's demo, right, as I'm pointing things out, what I want you to be paying attention to is what does it mean to treat something as a value, right? What does that mean? Right? And specifically, like even more specific, what does it mean to treat a function as a value? Right? Now this question, it's not going to make much sense right now, right? But I'm going to bring it up over and over and over again over the course of the lecture. And it's going to be essential to the way that JavaScript sees the world and the way that JavaScript interacts with the world. Now, I have used the word value. I've used the word value, and I'm saying in JavaScript, some things are values. What are some examples of JavaScript values? Sure, primitive types. Yeah. So let's get a list. All right, we got numbers. We've got booleans. And it's numbers. The usual suspects. We've got 10, 5.2, -4. These are all numbers. Booleans. Really just two of them. We got true. We got false. I don't know if you've seen. I was going to come up with something silly, but it's just true and false. This is going to be like trolls. That's real programmers code with trolls. All right, we got numbers, we got booleans. What else do we have? Cool. And we got some symbol. Sweet. We got all kinds of stuff. Let's come up with one more. So a variable is a place that you can store one of these values, right? So JavaScript values can be stored in variables. And we're going to play around a lot with that idea today. Right? But what are some other values? Yep. What's that? Null? Absolutely, sure. Null. Arrays, cool. Objects, that's the one I was waiting for. Objects. Objects are by far the most interesting, I think, of JavaScript values. Is today's lecture about objects? Absolutely not. But soon you will explore that stuff. There is one more in here, or rather that isn't here that should be here. Yeah, functions. they are values. So functions. You're going to see exactly what that means. Now, I'm going to be hopping between a couple different windows as I do this demo. I'll explain why I do this. I don't mind working in Node, like in here and going 1 + 1 is 2 and working there. But I specifically really, really like working in the browser because when I'm at the browser, I can open up a little window. And I like playing in the console that the browser has. So I don't know if you've seen this before. Generally, whenever you're on any tab, if you right-click and go inspect, you can find a console to play around in. Right? So that's what I'm going to be working in for some of the demo, and then I'll be moving my code over to a script. Just want you to know why I'm doing that. The reason I really like doing this is I like the colors. Look at that. It's blue, it's orange. Like, it makes a difference. If I was doing that over a Node, it's like, ugh, it's no colors, man. Like, so that's the main reason. The other reason for it is when I make something like an object. So actually, how do I make an object? Yeah, curly braces, right? So boop, that's an object. Something that the browser lets me do, the browser console, is see the little arrow, I can open it up. Right? So this is supposedly an empty object, and then I click it open. Brodo! I don't know what that is. That's not the topic of today's lecture. So I'm going to be working with things like functions. Now, how do I make a function? Let's make a function that adds 2 to a number. Cool. So const, and then say my function's called add2. I'll go add2 equals, and then what do I write on the right-hand side of the equal sign? What's that? I write the word function. Right? And then I can make my little curly braces. And if this is a function that receives a number, I'm saying add2 is going to be called like add2 4, and then it should return 6. What do I need to do to this to make sure that it takes one input? Yep. Add a parameter, right? So I'd go here and I'd say, OK, this function takes a number. It takes a number, and then in here, if I want to make sure that the function adds 2 to that number and gives it back, what do I do? What's that? Sweet. OK, return. And what do I want to return? So I want to return this number, but increased by 2. This number plus 2. So it's not going to be plus equals 2, because plus equals is going to have something on the left-hand side. We're on the right track, though. Number plus 2. And so this is a function that receives a number, and then it returns that number, but it's been increased by 2. So if I go add 2 now, I get add 2 and 6. Right? Okay. This is the basic structure of a function. I want this to be like right in here. Every single time you think of a function, let me put this in the notes. Every single time you think of a function, it should contain the idea of some input and something being returned. Right? Interestingly, some other parts of this are actually kind of optional. Right? So we're going to talk about which parts of this are optional. And to make a good function in general, you're often going to need to say, this is what this function takes. Maybe the function doesn't take anything. That's OK. Like, it doesn't take anything. That's fine. But we need to have a space to say, if we wanted to give it something, this is where it would go. And most functions are going to have a return statement. Right? Most functions are going to have at least one path that spits something out. In general, when we're thinking of functions, you can go Sketchpad, draw a little. In general, when we're thinking of functions, they're going to be this box that take one or many things in. Right? Or you know what? We could even say 0 or many things. But some number of stuff is able to go into the function. And in general, in JavaScript, one thing can come out. Right? So JavaScript will let us return a single thing out of the function. And I want us to think as functions as these boxes that we can put stuff in and stuff comes out. Now, there's something interesting about the way that we declared this function. And the thing that's interesting about this is that this here, what does the left-hand side of this situation look like? What do we use the word const for? To declare or store something, right? So we're making essentially a variable called add2, right? And we're putting something inside of it. Right? So in the same way that I can go let let food equal potato, right? I've gone const add2 equals something else. Now with a let variable, what can I do with this? I can change the food. So what is a food? Anybody got food options? Food equals bagel. Right? I'm going to find that before I run that code, if I go console.log food, I have potato. Right? If I go food equals bagel and I go console.log food, I now get bagel. right? So I've gone from having potato in there to now having bagel. Okay, so I can have a variable, and I can change around the value that is inside of that variable. Okay, a variable is very much, we'll just move down here. A variable is very much just a box, and I can choose to put one thing in there, right? Or take that thing out and put something else in there as I see fit. Variables are kind of like the program's memory, right? It's like JavaScript's memory of something. And you're able to wipe that and put other stuff in there. Now, the interesting thing about this is like I can make a function like do thing with let instead of const. And I can go, okay, let do thing, and this is going to be a function that console.logs, haha. This is a function that I've made that apparently doesn't actually take in any input. There's still room for input, but I'm not declaring any. And it also doesn't return anything. Sort of a useless function. This one just console logs, haha. Right? Functions in general are good for like wrapping up a bunch of code. What I'm able to do right now is I'm able to go do thing and call it with parentheses. Right? So what happens when I do that? It prints haha. What happens when I do this? So one thought might be that maybe something's undefined. Right? Well, you see that when I do this and I press enter, what has it done? It's printed out the actual function. It just shows me, all right, well, here's the function. Right? I can hold a function. I can hold a function and it's not doing anything until I tell it invoke, right? Like run. To kind of have a bit of an analogy, there is a difference between me pointing out the light switch and using the light switch. Right? The light switch is this thing that can be used to like enact something. And I'm able to say, oh, here it is, without turning the lights on and off. Right? And that's what I'm doing right now. I'm just showing you, okay, well, here's the function. I'm not running it. But in case you wanted to, there it is. Right? And then when you actually want to run it, you can go do thing with parentheses, and then it will go haha. Right? And what I want you to see is that this is a legal thing to do in JavaScript. Right? Is it legal in all languages? No. Right? There are some programming languages where you're not allowed to do this. Right? But the designers of JavaScript made this decision. They said, hey, you know what? Functions can be a thing without running the function. Right? I can actually refer to a function without running it. And that's going to be useful. Right? That's going to be useful for a couple different reasons. One of the reasons is exactly that light switch idea. Right? I can tell you where the light switch is. And like, why would I tell you where the light switch is? What purpose does that serve? So somebody else can turn it on. Right? Like, I'm not the one who's doing it right now. It's not even happening right now. It's just that I know that you might want to turn the lights on or off later in the future. So I tell you, hey, here's the light switch. Right? That same kind of idea can happen with JavaScript, right? Like we can code that motivation of, hey, I know that you don't want to do this thing right now, but here is what this thing is in case you want to do it later. Right? I want you to start thinking of the difference between like telling someone about an action and actually performing that action. So the idea of an action existing and the idea of an action being performed are two different things in JavaScript. Right? Now that idea, it's going to take a while to like sink in. It's going to take a while to see the actual ramifications of something like this in a language. Right? But I'm going to do my best to show you in like a limited scope. In a limited scope right now, how that can be useful. Before I show you any more code, does this idea make sense? And are there questions? Yes.
Just curious, like in the browser,
Mm-hmm.
like we see like that undefined almost every line.
Oh, yeah. So, so what the browser's doing is, anytime you run a single command, right? Anytime you run a command, what it does is it runs that command, and then it'll show you all the things that command does, and then it'll show you the return value of that command. So that's something sort of specific to the place where I'm working right now. So for example, when I console.log something, I get asked and undefined. That's what you're asking about right now, right? So console log, when you tell it to console log asked, it prints out asked. But what is console log? If I'm calling it with round brackets, what kind of thing is this? It's a function. Right? Console log is a function. And presumably, console log does not have a return value. So the browser, by default, also prints out the return value, and it prints it out specially with this little arrow and a dot. And it's just like extra stuff that kind of came out of that function. So for example, my add2 function that I saw earlier, it returns the number 2. Whoops. It returns the number 2. So if I was to go add 2 to 4, notice that it doesn't have undefined there. What it has instead is the little arrow with the dot saying that the return value of add2 is 6. Right? That's about as much as I want to say about that right now. Don't worry about it too much. When you're actually writing like this code out, and as we're going to see when I write out a script, I'm not going to see undefined everywhere. But that's a really good thing to kind of peek at. Does that answer your question slightly, at least? Cool. Any other questions?
So in other languages, can you not tell people about the function? Or is it?
In other languages, they might have other constructs to do that. Or they might have found like, we're going to see that the reason in the future, so not today, but we're going to see that in the future, the reason that we are able to do this with functions is to solve specific problems that JavaScript was designed for, right? Specifically, it's like the fact that JavaScript lives in the browser. There are like, sort of like other things about it, but like other languages get around with like a different worldview. Or like functions might not be as important as they are in JavaScript. Or in some other languages, such as Ruby, for example. In Ruby, you have the idea of functions, but then you have the idea of something that's sort of like a function, but instead you're able to pass it. Right? So this idea gets split in two in other languages. You could design your own language that has multiple kinds of functions or stuff like that. But this is how they've decided to do it in JavaScript.
You said you can store different stuff in a variable.
Mm-hmm.
So, but is constant a variable? Is it from the variable family, or is it something else?
So in JavaScript, we have var, const, and let. Var you should never use. Just don't use var. Let's not talk about it. Const is they're technically all variables. Var just is named after variables, which is confusing. But const is a variable that you cannot reassign. You store it, and then you can't reassign it afterwards. Let is a variable that you can reassign. Right? So that's a good question. If I have const pizza is cheese, I cannot go pizza equals anchovies. Anchovies. Like I can't do this, or JavaScript will get angry with me. If I do let ramen equals pork, so this is let, and then I go ramen equals veggie, that is legal. Right? That's the only thing that's like a difference between const and let for us right now. Now, the thing that I want us to focus on right now, though, is this idea of, in fact, that I'm able to refer to a particular function. So add2, I can call it without parentheses. Or do thing, I can call it without parentheses. That's going to be interesting for us soon. Bless you. Now, I'm going to make another variable. Right? Or am I? No, you know what? I'm not. Here is my do thing from earlier. So I went do thing. Do thing is this function. right? So I'm going to just make sure that that's saved somewhere. So do thing is this function that console logs haha. I can go do thing equals, and this actually feeds into your question about reassigning. Do thing equals, and I can reassign this to be a different function. Do thing equals and console.log boo. Since I declared my function with a let, right? This is a let variable. I can reassign it. And I will see now that when I go do thing, I get boo instead of the haha that I was getting earlier. And this is neat. It's this box where I have switched out the value that's inside. And I want you to see the distinction between the box, which is the variable, right? The let or const, right? The box, and the actual stuff that you put inside of the box, which is the function, right? The function itself. This idea can be really, really powerful for us. So I'm going to do something here. I'm going to go let say hello equals, and this is going to be a function that console.logs hello. Right. I could have done that with a const. It doesn't really make a difference. Let say goodbye equals, and then function. And this is going to say in here console.log goodbye. So I have two functions, say hello and say goodbye. And if I wanted to call say hello, I go say hello, and then I invoke it with the parentheses. Now, I am able to make yet another function. Here's one. Let thing to do, or we'll call this greeting. Yeah, greeting. I know goodbye is not a greeting, but I'm having trouble coming up with a different name. Let greeting equals, and then say I want my greeting to be say hello. What can I do? Cool. So like what keys do I press to do that? I want you to spell it out for me. Sweet. Let greeting equals say hello. This is bizarre, right? It might feel very bizarre because you might have been thinking so far about functions as this special thing. Functions are not special. Functions are values just like objects, just like strings, just like booleans. Right? I can go, this variable called greeting is going to be the value of say hello. Like greeting equals say hello. And now what I'm able to do is I'm able to actually call greeting. Greeting, if I run it without parentheses, it is a function that console logs hello. Whoops. A function that console logs hello. Meaning if I wanted to run a function right now that printed out hello, what would I be able to do? I'm able to go greeting and then invoke that. And the thing that is infinitely funky about this is that I'm able to go, let's now change what the greeting is to say goodbye. Right? Say goodbye, and now I'm able to go greeting. And now my greeting is goodbye. And when you get rid of the thought of functions as being some sort of special thing, you can treat them as any other value. Right? And what is the thing that made this possible? The absence of the parentheses here. And the fact that I am not calling say goodbye on this line, I am passing say goodbye. Right? I can call a function or I can use a function as a value, right? Which I'm going to sometimes call passing. Now, I know that today's lecture is all about callbacks. Right? I haven't even said the word callbacks in the demo so far. Right? But this is going to be central to the idea of how callbacks work. Somewhere where I find a lot of people get stuck with callbacks, right, as you're going to see soon, is they try to think of callbacks as this brand new kind of idea. And it really isn't. And before I even show you what they are, I want you to think of this. I can go greeting equals say goodbye, and this is a function. It's not a function call, but it is a function. Yeah.
So now if you change greetings, stuff that's inside of it, would it affect the original function, or that would be the same?
If I was to change the stuff inside of greeting,
Yeah.
how do I change the stuff inside of greeting?
Like console, like something else.
So I'm not able to edit a function. Like I'm not able to edit the content inside of a function after I've written it. Right? So what I would need to do is like scroll way back and edit one of these, but I'm not able to do that. Right? These are like lines that are happening one by one. So in fact, if I was to write this out as a script, like we're going to call this one functions are values. Right? What we did here was we started off with the idea of let food equals, what did we say? It was potato, and then we went food equals bagel. And we saw that this was legal. I can also do, like we just did right now, this was the say goodbye and the say hello. So this was say hello, this was say goodbye. Oops. So say goodbye, and then our greeting could be say hello, and then I could ask you, okay, well, run greeting. You know, what does this do? And then we could go, okay, well, greeting is say goodbye. And I would run greeting again. What does it do now? Right? We've run each one of these lines one by one, is what we've been doing. But I could run this. I'll comment on the food part. I could run this in Node if I wanted to. Node functions are values. And when I run this right now, I get hello and then goodbye. Okay. So over here, I've been running stuff line by line, but I could write it all out as one script. And this is likely what we're going to be playing around with more, is writing stuff in scripts over the course of the demo. It's 10:41, so we still have some time. So this is fundamentally, like, I think, kind of cool. Right? It opens up the possibilities a lot, because what I get to do is then use a single word, maybe, to refer to different things. My greeting may at some points be say hello, and it might at some points be say goodbye, and may at some points be something else. Right? I could use this greeting. It might be dynamic. Who knows? Maybe, I don't know this right now, maybe, but like as part of my program, the greeting just changes. Like the greeting itself changes over time, and I could just call greeting. Right? I'm just thinking hypothetically here. So I have this function here. It's a fairly basic function. It's a function that really isn't using any inputs and isn't returning anything. And I start making functions that take inputs. And I'm going to call this functions2 electric boogaloo. All right. So you can make a function, and this one's going to be add two numbers. So this is a function that adds two numbers together and returns the numbers after they've been added. Right? So what would I want to do up in the parameters, up in the arguments? Except two numbers. So I might go A and B, right? Or number 1 and number 2 or something. I'm going to stick with A and B for right now. And then my return value, I want to return the two numbers added together. Right? Return A plus B. I'm going to do the same thing with like multiply two numbers. So here's a function, A and B, and this is going to be very similar, but it's going to go return A times B. Right? And it should come as no surprise that when I console.log, add two numbers, and my numbers are 10 and 5. What should I get? 15. And then when I multiply two numbers, lo and behold, I get 50. Right? So multiply two numbers, I should get 50. And I could verify this. I'm going to run node functions 2. And I got 15 and 50, which is cool. Now, very much identically to what we did with the example over here, I can make maybe a function called doMath. I'm going to go let doMath. This is a variable that is going to hold some function. So maybe let doMath is add two numbers. And now when I do math with 7 and 4, something special happens if I console.log do math of 7 and 4. Right? When I run this, and I got 11, because my do math was to add the two numbers. And if I was to, again, do the same thing where I go do math equals and then point this somewhere else, like multiply two numbers, it should also come as no surprise that I can do math with the exact same thing, and the same line of code gives me a different output. 28. So the reason I'm going over this multiple times is I want you to see what could be the potential value of having a generic line of code. This is a generic line of code that says console log do math with 7 and 4. Do I know what the math is right now? No, right? Like as I look only at these, let me move this way down. If I look just at this line of code, I don't know what do math is. But I can assume from this line of code, I'm going to do some math on 7 and 4. Right? It's a generic line of code. Right? But it lives with some more specific context of what do math is. So when I look at this, it's like, depending on what do math is, I'm going to have something else happen. Okay. And I want to encapsulate this idea. I want this to be something that I can actually use in my programs in a way that's useful. For me to have to like manually write this out every time is infeasible, partly because I might not know when these values are supposed to change. Like at the time of writing my program, I might not know, or I might not be able to specify that do math should first be add two numbers and then multiply two numbers. Right? For example, I might want this to happen when somebody clicks a button to switch between math types. Right? I'm just thinking of like a hypothetical idea here. Now, to kind of answer this kind of question, you need to take a slight detour. If I wanted to make a function, I'm going to make a function, and this is going to be do stuff. Okay. Yeah, nice. It's going to be a function called do stuff. And what I want to do with do stuff is I might do this in a separate example just so that there's less code in here. What are we going to call this? Mystery demo, because we'll find out what the name of this demo is soon. The name of the demo is a spoiler. So, I have my math functions. Add two numbers and multiply two numbers. Before I continue, are there any questions at all about those two functions? Cool. Want to make sure we're all on the same page. OK, so add two numbers, multiply two numbers. And then I'm going to make a function called doStuff. And what my doStuff function is it is going to receive some like thing. It's going to receive something, and then it will be running it in here. But I think I actually want to make you think about this a little bit. What kind of stuff can I put as an argument to a function? Right, what kind of stuff have you seen get passed into here? Values, right? So like, give me an example of maybe some of the values that you have passed to functions in the past couple of days. So you've passed in numbers, right? So it's common for us to do something like we did add 2 with the number, sure, add 2 numbers, 2 and 5, right? What are some other values that you've passed? You've already passed functions? Yeah. Oh, snap. All right, we've passed functions. We're going to pass a function in here. We're going to go, okay, well, this thing is going to take some math function. Some math function. You did that towards the end of yesterday, didn't you? Yeah. Yeah. They slightly changed the curriculum on me. We can pass in any value. And out of our list of values that we looked at in the notes that we were writing earlier, our list of values is gigantic. We could pass nan if you wanted to. We can pass some functions. Right? And I'm going to say that this mystery demo here, my doStuff is going to take some math function. I might not know what this math function is at the time. But something I can tell myself is math function will be a function. And I can write this out in a comment to myself. I can say, heads up. In case you're wondering what math function is, it's a function. What can you do with functions? You can call functions. You can call them. Meaning on this side here, even though at the moment of writing this code, I have no idea what math function is. There is no declaration for math function anywhere. I can say that given a function, I would run it. I would run math function on, maybe 4 and 5. Right? Again, there is no function being declared anywhere here that is called math function. Right? There's no function being declared called math function. But if I was to go doStuff, I would now be able to say that the math function that I want you to do stuff with should be, for example, add 2 numbers. Right? That's the idea that I want to get to right now. Now, if my 2 options for functions are add 2 numbers and multiply 2 numbers, and I'm telling you that I want you to pass add 2 numbers to the doStuff function, right? What would the syntax for that look like? What would you imagine? Cool. And do I have to do anything else? What do I have to do? Pass the parameters for add 2 numbers? Right. So what is missing from this? And again, it's something we talked about already. What is missing from this that one would usually expect with a function but isn't being used? Yeah, so like in general, just the 2 things here, right? Like the brackets, right? But since we are not calling the function, we are passing the function, right? I don't use the parameters because I'm not invoking it. I'm saying, hey, do stuff with the add 2 numbers function. And then we get in here, and the add 2 numbers function, what does it get renamed to? In here. Exactly, right? So the add 2 numbers function, as soon as it enters doStuff, it gets renamed. It gets renamed math function while it's in here. Right? And if I run this right now, I'm going to see that when I go do stuff with add two numbers, so this is node and then mystery demo. I forgot to put a console log in there. Console log. I could even go, yeah, we'll just go console log do stuff with add two numbers. Yep. Boop. OK. I'm calling the math function. The math function, whichever one it is, returns something. I need to make sure that stuff is passed all the way up. Now we got 9. Right? So do stuff with add two numbers. So add two numbers gave me 9. But if I was to do stuff with multiply two numbers, I'm getting 20 now. Where I've been able to make a generic function. Right? And we're going to be spending the entire second half of the lecture going over this exact idea. So if it's not sinking in properly, don't worry. Like, we're passing over this multiple times. But I've made a generic function. And I'm passing it functions as parameters. What do you think this idea is called? What's that? It's called a callback. This is a callback. Right? Now I've made a slightly contrived example of a callback. Right? When we come back from a break, I'm going to make a couple different examples. And I'll show you examples that make it a little bit more clear why we might want to use this kind of pattern. At the moment, are there any questions? Cool. Is there anyone who's like confused about any of this stuff? Yeah.
So on line 20, does JavaScript, does it move from the inside of the parentheses to the inside to the outside part?
Mm-hmm.
There were like 4 more functions inside of it. Which one would it execute first?
So it goes multiply two numbers is not a function call. That's a value. I'm passing multiply two numbers to do stuff. Right? This might be easier without a return statement, so I might rush through the explanation and then just clean it up for the second half. Basically, we're doing stuff with multiply two numbers, and then we're console logging whatever that returns. So do stuff returns whatever the math function on 4 and 5 does. And so we'd have to go deeper and see what the particular math function, which is multiply two numbers, we'd go deeper and see what that one does. Right? That's a good question. In fact, I think what I'm going to do is I'll start the second half of this lecture analyzing that and kind of digging that apart a bit. Is that OK if we just wait on that? Cool. Any other questions, though? Cool. So what we're going to do is, how do you all feel about I'll treat you. Do a 13-minute break. Yeah? It's like 10, but I'm giving you 3 for free. Yeah, I'm generous. No, it's just so we end up with a nice number. So we'll get back at 11:10. Cool? Cool.
Okay, so first class object
Mm-hmm.
means I can do whatever I want. I can change it. It's like a variable. I can replace it, change it, use it.
Yeah.
If someone asks me what is a first class object, is
Yeah.
that?
Exactly. First class. When some people say that functions are first class citizens or first class objects,
Yeah.
that means exactly what we did. We're like moving it into different variables and reassigning, and what we're gonna be playing around with in the second half is passing it into functions. Right?
Okay, and
Yeah.
a first
So
class.
exactly what you said is right.
Okay, first class function is a function that use a callback function.
No, no, no. When we say that in JavaScript,
And
function.
higher something function.
Yeah, so we're going to talk about higher order functions
That's what-
towards the end. But when people say first class, that means that there's nothing special about functions. Like they're like every other. Whoops. They're like every other value.
Okay, and higher class function.
All right, what's up? We're gonna get going. So, all right, a rowdy class. Yeah, it's so rowdy. You know what I learned? There you go. Yeah. I have taught like an insane amount of children's workshops. Before I worked at Lighthouse, I've been at Lighthouse for almost 2 years now. But before I worked at Lighthouse, like I would exclusively teach children, like children's programming, like 6 to 13 for the most part. They are hard. Yeah, for like weekend workshops, like kids working with. I don't know if you've. Hey, what's up? Yo, Jaden. Really, all of you. Grayson, what's up, crew? Lecture's happening, y'all. All right, thanks. I used to teach, I still do sometimes, but Scratch. Scratch is the only good programming language. So, I mean, y'all work with JavaScript, whatever. It's eh. Scratch is the only language where you can control cats.
Oh, I think I've seen. They teach this in the elementary curriculum.
Yeah. Actually, I spent a good half of last year traveling across Canada teaching people this tool. I would teach. I taught like conferences for teachers, like Pro D-Day conferences. So it was like every other weekend I'd just go to a different city and be like, all right, if you want to move the cat to the right, you drag the little block over and then you click it, and every time you click it, it goes to the right. But if you want the cat to go over to the right every time you click the green flag, you can go to Events, and you can say when the flag is clicked, then it moves over. And if I want to say that when the flag is clicked, the cat moves over 10 steps 5 times, well then I'm going to need a for loop, which we would call repeats. So when flag clicked, repeat 10, move 10 steps. So I go and click the flag and whoop, whoop, whoop. There you go. So you can do some bizarre stuff with this. It's pretty cool. But yeah, I spent way too much time with this. And you can edit little cats.
So it's like a learning tool, basically. You can't like create your own functions.
Oh, you can absolutely create your own functions. One would think you couldn't, but this is surprisingly sophisticated. You can go and create your own blocks, and blocks are functions. You go make a block, we'd call it something. You can give it inputs that are numbers, booleans, a name. And then, yeah. So there's you could probably do callbacks here as well. I think maybe for the next cohort, I'll figure out a 2-hour lecture on callbacks in Scratch. For today, I probably won't. But I do highly recommend playing around with this. So, long story short, though, yeah, I've taught a lot of kids stuff. If I do birthday parties, if you have cousins or whatever. Or if you want a lesson in Scratch, I got tons of material. Yeah, shameless plug. Yeah, check out my mixtape. Yeah, I'm a struggle coder is what I am. So what we ended up doing at the end of the first half was, at the very end, I got into using callbacks. And I actually used a bit of a contrived example. We're going to take a step back, work a little bit, and then move our way forward. And we're actually going to go beyond what we did in the first half. So in quick summary, fun fact, functions are just values. Right? You can reassign them. Right? You can reassign them if they are let variables. Right? You can totally reassign them. You can pass them as arguments. And then note, as long as you don't invoke them. Right? As long as you don't invoke them. Again, this is high level. We're going to loop over this a couple times. Now, the thing that I realized about the demo that I was doing was, like, I threw in a couple things that are not really necessarily related to callbacks. For example, return does not really have anything to do with callbacks. Right? So in my next demo, I'm going to get rid of that. The other thing that I realized I did was, like, I gave this thing arguments, not even really necessarily related to callbacks, so I'm going to take that away. Right? The next demo, I'm going to strip down callbacks to the very, very, like, basics of it. I'm not saying it's going to be easy, right? But I'm saying that there's nothing more that you technically need to understand callbacks other than the example that I'm going to build up in a sec. It's the best example. You have no idea how good this example is going to be. So we're going to make callbacks.js. This is just one file, callbacks.js. I'm going to bring back our usual suspects, which were say hello. Whoops, let me not do that function. Right? And this one here is going to console.log hello. Right? So this is identical to the functions that we were making before. One that says say goodbye, right? And this one says goodbye. And one that says greeting. Right? So before we did this with a variable, I'm going to make a function called say greeting. And this is going to be given a particular greeting. Right? Given a particular greeting, I want to say that greeting. Right? Now, I'm going to go in here and I'm just going to console.log greeting like this. Am I invoking greeting at the moment? Can you put up your hand if I am invoking greeting? Okay, can you put up your hand if I'm not invoking greeting? There you go, cool. I'm not invoking greeting because all I want to do is just see what greeting is. And I'm going to go say greeting for say hello. And the reason I'm doing this is because when I run this right now, what got printed out? The say hello function, right? It's showing me that the greeting is say hello. Right? To make this even clearer, the greeting is the say hello function. Right? If I was to do that with say goodbye, then I would see that the greeting is the goodbye function. Right? And the reason that this is nice is because what I'm able to do is I'm able to go in here and go greeting. Right? I'm able to actually invoke the function that's being passed in. When you see, if I zoom in right now, I do not know what greeting is other than the fact that somebody's giving me a greeting. And when I run this right now, I get hello, goodbye. if you are struggling with callbacks at all today or tomorrow or over the course of the next couple of weeks, I want you to come back to just this. This is a callback. Right? This is the basic idea of what a callback can be, meaning I am passing a function to another one. Right? Without adding extra stuff to this, are there any questions about just this demo? Right? So notice there's no return. I haven't even done argument stuff. Like I didn't even put arguments in. Arguments are cool, but they're not core to the idea of callbacks. Cool? And we can use this to do things that are more complicated than just having a generic, say, greeting function. Right? So one of the examples that I usually like to use when I explain this stuff is, let me make a new file, is called go fetch me a thing. So generally, callbacks, they're a pattern that arise out of the fact that JavaScript lets us use functions as values, right? Callbacks are not a real thing. Like callbacks are not a thing that like was made in JavaScript. They're a result of the fact that functions are values. But I can make use of that pattern to solve particular problems. And one of those problems is that I might want to inject functionality once in a while. And so we're going to make a couple different functions, and I want to combine them in interesting ways. This one is, should I call it go fetch me a, we're going to call it go to the. Okay. We make a couple different functions. One's going to be called go to the cobbler. One's called go to the cobbler. One is called go to the store. One might be called go to the, I don't know, what other things are there in small towns? Maybe not. Go to the, we're going to go to the library, right? So I'm going to say that, like, go to the cobbler. This one just prints out a shoe. And it says, I went to the cobbler. Right? The store is going to do something else, and the library is going to do something else. So I went to the cobbler. I went to the store. And this one is, I went to the library. We're going to go library. Cool. All right, that's a credit card, but I guess it shows up as library card as well. We're just going to go book. And we're going to do books. And I went to the library. So these are three different things. Ideally, I could say, OK, go to the cobbler and run it. Right? And this is going to do go to the node, go to the. I went to the cobbler. No big surprise. Where this becomes interesting, though, is if I have a function called go to town. Right? I'm going to make a function called go to town. This function is going to say, I went, or I'm going to town. Going downtown. Making my way downtown. And then while I'm there, I want to do some stuff. Okay? Maybe there's some things that I want to do. Like when I go to town or go downtown, I might go dancing. And then here I am dancing. And then I might also want to go to the fair. go to the fair. And in between dancing and going to the fair, I'm going to make time for one single thing that you want me to do. Right? You make time for a single thing that you want me to do. I'm going to make space for that. So I'll do something for you while I'm in town. Right? So let's imagine that you and I live on a farm somewhere. I'm going on my weekly downtown trip. I put on my downtown clothes, put on my downtown dancing shoes, right? And you have to stay at the farm to look over the chickens because we take turns. And you say, okay, well, while you're going to town, could you please, like, my shoes are falling apart. Can you please go to the cobbler? And I will say, okay, fine. I'm going to go dancing, then I'm going to go to the cobbler, and then I'm going to go to the fair. Right? So I might have to make a function called go to town and make sure, and while you're there, go to the cobbler. Right? So here's a long function name, totally legal. But I'm going to say go to town, and while you're there, go to the cobbler. So in here, it's go to the cobbler. And if I was to run this right now, go to town, and while you're there, go to the cobbler. I'm going downtown. I go dancing. Okay. The terminal can't print out like so it's a dancing person and then a skin tone. And then so I go dancing, then I went to the cobbler, and then I go to the fair. Right? Totally fine. Now, if I wanted to make another one that was okay, go to the town, and while you're there, go to the library, I have to make a second function. Go to the library, and then I would switch this around with go to the library. And then I can run that function instead. Right? Going downtown, I go dancing, I went to the library, and then I go to the fair. Right? This is legal. This is totally fine. It's not the worst thing in the world. But what are two things that are bad about this? Right, the name is too long. That is one kind of terrible, terrible thing. You will find as you're programming, sometimes in different languages, there's different conventions for how long names are. So if you look up like JavaScript function name, not JavaScript, Java function names, you'll find that like Java function names get like really long sometimes. Yeah, you got to look up memes. There you go. So here's, a function called test1. Get unread messages and notifications by mobile scan account ID when database result returns no results, then return empty list. Like that's a good function name. You look at the function name, you're like, I know exactly what this function does. Yeah. So yeah, in some languages, like there's weird conventions for. I don't know. Like it's pretty weird. So that's one thing. The function names are too long. I could totally just shorten the function names. That's totally fine. What is another thing that is bad about what I have here? I have to make a new function for every new place that I want to go to, and specifically there's a word. There's a word for what's going on right here, and it's called duplication. Right? I am duplicating code. Right? Duplication, not always the worst thing. Maybe two functions are very similar, slight difference, but they're small enough that you just make copies of the functions. Right? But eventually this stuff can blow up. If there were a billion different things that I could do while you go to town, I'm going to have to make a billion different functions. So what I want to do is I want to inject functionality. Right? I want to inject, okay, well, go to town, and while you're there, this is what you should do. Right? So what I might do is I might improve this situation by saying something like const go to town, and then this is a function that's going to take something to do. Right? I might call this and while you're there. I just came up with a name for it. Go to town and while you're there. So maybe now my function is going to look like this. It's going to say, hey, I'm going downtown. I'm going to go dancing. And while you're there, and then I will go to the fair. Now I get to call go to town, and in here, if I wanted to say go to town and go to the library, where'd my library go? Oh, because I wrote, all these were poorly named. Go to the library, go to, yep. So go to the library. Now I have a function that executes a custom piece of functionality, right? And that is really the basic thing that we want to solve with callbacks, is we're injecting functionality in there. I'm going to town, I'm going dancing, I went to the library, and now I go to the fair. And what I've been able to do here is I've been able to write a function that does not care what other functionality gets injected into it. Right? I'm just open. Give me something to do. Right? Go to town and go to the store. So now I'm going downtown, going to the library, and then the next time I go, I'm going downtown, and I go to the store. Right? This is a silly example. Right? I don't think it's very often that you're going to be, as a web developer, making a full-fledged simulation of people going to the store. If you go work somewhere and they're like, all right, like this is what we're going to do, like run. It's not worth it. There's no money here. But it's good as a demo. Right? Instead, as you're working through the activities today, as you're working through the activities tomorrow, and really over the course of your career as a developer, right? Whenever you have a function that could take some injected functionality, right? Some dynamically injected functionality, that's probably a place where you'll go, oh, I could make a callback happen here. And this thing here, I could technically have broken go to town into two functions. Right? I could have done go to town part 1, and then I would run my extra functionality and then go to town part 2. Like, there's nothing stopping me from breaking this into two functions and doing that instead. But it's more elegant for me to be able to inject code in. Cool. Does that motivation make sense? It's all based around the fact that I need to have some functions that get other functions passed in. Now, are there any questions about this particular example at the moment? Yep.
So is this how we can tell a function has a callback in it? Is when and while you're there, it has to be inside the function and
Yeah, if I was to break down like Nima's tips on is it a callback, it would be look at the arguments of the function and then check to see if those arguments get called anywhere as functions. Right? If that's happening, you got a callback. Right? That's the way that you can like sniff these out. Often, these things will have generic names, such as callback. Right? That like is really common. You'll just see things being called callback or CB. Right? I like giving them descriptive names of what that function is supposedly like used for. Now, do you have any intuition as to like why they're called callbacks? So eventually, I am calling this function. Eventually. I am not calling it when I call go to town. I pass it, but I pass it with the knowledge that this function will be called back. Right? I pass it with the knowledge that eventually this function will be called. It's not being called right now, but it will be. Right? I'm essentially handing over control. Because I might have not written the go to town function. That might be a function that was made by somebody else, maybe. But the person who made that function has allowed me to inject my code into their function. They're allowing me to put my own stuff in there. And the way that they've enabled that for me is they've said, OK, you know what? To this go to town function, you can pass a callback. And I will find that stuff usually in the documentation. Right? Usually when I inherit some code or when I'm using a library or something, there will be documentation that says, hey, the go to town function will accept a callback. And they'll also tell me the callback will run at the end of the function. Right? Or the callback will run when this particular thing happens. We'll be told when the callback will run. Now, I want us to think about this. If I had, here's a function that I'm calling console log num, and I have let num equals 2. I want us to think really, really hard about how we can rewrite this. Just those 2 lines of code, how can those be rewritten? So why string? This is a number, so there's no string here. But it's heading in the right direction. I would go console log and then something. Yeah, I could go console.log2. Right? So I could either write this on 2 lines or I could write it on 1 line. Is one of these better than the other? Absolutely not. They're just 2 ways of writing the exact same thing. Right? Now, I want us to look at this. This here was console logging something that had been declared previously. This one here is console logging something that I'm declaring right now. So what could I possibly do with this kind of situation, but following the same idea? Yeah, absolutely. Can you say that louder again? Yeah. Mm-hmm. Cool. And where do I define that function? Yeah. Exactly. Right. So in the same way that I can define 2 inside of the parentheses, I can go to town, and then instead of having previously declared a function, I can say, and here is the function that I want you to use. Right? This looks freaky. It looks so weird until you realize that functions are just values. Right? Go to town, like I might as well have passed the number 2. Here I'm passing it a function that is being declared inline. Right? Go to town. And then like you said, I don't have to give this function a name. Right? What kind of function is this? It's called an anonymous function. Right? It's a function without a name. Right? So I could say go to town, and then in here, maybe what I want to do is instead of going to the library, going to the store, go to, I don't know, what other things are there? Go to Japan. That's in town. Okay, yeah, City Hall. See, the thing about the farmer's market is that we're already at the farm. so all right. We're going to go building. There we go. Go to City Hall, and that's going to be this one here. Okay, I went to City Hall. And I'm declaring that in line. Right, let me comment out everything else just so that there's no other things being console logged. Go to town and City Hall. I'm going downtown, go dancing. I went to the City Hall and go to the fair. Right? So actually able to inline inject stuff. This is not something that you necessarily need to be super comfortable with right now. Right? That's totally fine, but I want you to at least make the connection between this and this being the exact same idea. Right? They're the exact same thing. Right? Again, you don't need this for callbacks. Like, you don't need to even understand this idea because we can do it in multiple lines. Why would somebody do this? 2 reasons. One is they want to look funky and they want to have like things written in one line as opposed to like multiple. Yeah, cool hacker points. Like, that's really one. The other one is maybe you can't come up with a variable name. Like, okay, like I can't think of a name. All right, I'll just put it in line and I don't have to come up with a name for it. Those are the 2 problems that that solves for us. Right? Nothing else. Right? So if this is confusing to you, it's totally fine. Just do it in multiple steps. You don't have to do the stuff in line. So I'm going to say in a couple words, when a function receives another function and then calls it, this is not grammatically, like my commas are everywhere, but think about my emphasis. When a function receives another function and then calls it, right, you've got a callback. Right? You got a callback. That's it. That is what a callback is. A function when it receives something and then it calls it. Right? What problems do we usually solve with something like this? Right? Callbacks mainly solve duplication. Right? Duplication so we don't end up with lots of similar functions. And then the other thing is injecting our code somewhere else. So if I'm inheriting somebody's function, right, somebody has given me a function and I'm not allowed to change the stuff inside, they may have given me the possibility to pass a callback in. Right? And that's it. Right? Duplication and injecting our code somewhere else. Now, this here is actually a pretty big question. Like, why would we do this? Like, why would we? Yo, Aaron, Grayson, Mr. Dufall. Yo, sorry guys, it's just this room carries noise really well. Why would we do this? Like, why would we inject our code somewhere else? That's a pretty big question, and I'm not going to aim to solve that right now. Right? I'm not going to aim to explore that. You will be spending lots of time over the course of this bootcamp discovering different reasons for why we would want to inject our code. Right? And most of the time, the way that we do that is with callbacks. Now, it being 11:45, I'm going to make one last example. I'm going to talk a little bit of vocabulary and then let you go. This last example is going to be closer to the stuff that you're going to be doing for your assignments. In general, I'm going to call this function, this file here for each. In general, it is nice to have very generic functions. And the reason that we like generic functions is so that we can compose generic functions together to make more customized functionality. Right? Instead of having lots of very specific functions, we have lots of generic ones. We can kind of treat functions like Lego and clip them together. For example, I might have, you've played around with objects a little bit at this point? I think I might bring objects into here in a second, but I might have, say, a person here. So we're going to go let our const person equals, and then I'm just going to pick a very regular name, Bradlina. So I have a person, their name is Bradlina, and I might want to have a function called something like announce person. I'm imagining maybe this is like a fancy ball or something. People are arriving, and it's like like, and announcing Bradlina of house whatever, right? Like announcing people as they enter the fancy event. So here is the person. Announce person is going to receive a name, and what it's going to do is it's going to go announcing. Well, I need trumpets first. So there's going to be a bunch of trumpets, and then afterwards it's going to say announcing, and then name, plus name, the Magnificent. Magnificent. Right? So announce person, it just goes do do do, and then announcing name, the Magnificent. And I can use this with announce person. Right? This here on its own is cool. Like I can go node and for each, and I got announcing Bradlina, the Magnificent. Very useful function. I could use it as many times as I want, and I could use it in different contexts. Maybe it's a birthday party. Maybe it's a ball. Maybe it's at the beginning of a lecture, and I just want to like pew pew pew, Nima the Magnificent, lecture time. Like, you know, a bunch of different use cases for it. Very useful function. Another thing that I might want to do is I might have a list of people. Const people. This is going to be Bradlina, Christopheretta, Jamiestofino. And then anybody got friends? These are like my fan fiction friends. I go home, like anybody got a name? Bob. All right, that's Bob. So we got Bradlina, Christopheretta, Jimmy Stefano, and then Bob. And what I might want to do is I might want to announce each and every one of these people. So how can I do that? I could make a for loop. Right? I can go for, and then I could loop through each one of these. I'm going to be a little bit fancier than this. I want to make a function that just loops through people. I'm going to show you why. Here's me making a for loop that goes through every person and announces each one of them. For let I equals 0, while I is less than people.length, I plus plus. Okay, what does this whole situation do right now? It loops through all the names. And I could go in here and I could go, okay, well, for each one, I want to announce the particular person. So what I'm using is I'm using the index that I'm at. I'm grabbing the particular person, and then I'm announcing them. And to make this a little bit more legible, what I'm going to do is do this in 2 lines. Let the person, and then I'm going to console, or I'm going to announce person for the person. Does that lines 12 to 15 confuse anyone? Well, speak now or forever kind of, I mean, ask me later about it. That's totally fine. So when I run my thing now, and I loop, for each person I get announcing Bradlina, the Magnificent, Christopheretta, also the Magnificent, Jamie Stefano, and then Bob. This is cool. But if I had a second function, right, if I had a second function, you know, like, now I'm thinking, have any of you ever been to like Goo before? It's like a restaurant, Water Street. You like go in, people like say hello to you, and then when you leave, everybody yells at you, like they say hello, but it's or like bye. Except I don't speak Japanese, so I don't know what they're saying. But you could like announce people on their way in and announce people on their way out, and that's what we're gonna do. and then this would be leaving person. I don't know, leaving person, and then it goes do 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 do, and then now leaving, or you had been graced with the presence of, and then whatever the magnificent. So if I want to say bye to everyone, I'm going to need to straight up for loop again, and then leaving person. Right? For loop again, leaving person, and then run this. And now I've got the announcing and the leaving of the people. But what problem have I run into again that I was running into before? Duplication, right? So what I can do is I can identify the particular things about this function, right? And we've done this not backwards, like inside out, as opposed to what we did last time. I can now identify what things about this function are being duplicated, which is the structure around this, the looping around stuff, right? So I can take that stuff, I can extract it out and maybe make a function called for each, right? And this is going to be maybe a function that goes through every element of an array and does some action on that element. So for each is going to take, what is for each going to take? It's definitely going to take an array. And what else does for each have to take? It has to take a function, right? It has to take an array and a function to do on that array, right? I might call it action. I might call it thing to do. I'm going to call it callback, just to keep things simple. Right? For each is going to take an array and a callback. I want you to notice the language that I'm using right now, like the way I'm phrasing this, because that's what you're going to see in assignments. Make a function that takes an array and a callback. Right? And that's the way that you can explain problems to people. Make a function that takes a number and a callback, right? Or an object and a callback. Here's an array and a callback. And what I'm going to do is I can take this entire piece of functionality here and put it in there, and then replace announce person with callback. And what else do I have to replace in here? I have to replace people with array. Right? So maybe I'll replace that. Instead of people there, I'll go array. Instead of the person, since I don't know if I'm actually dealing with people at this point, I might go element. And then I might call the callback on the element. Notice that all I've really done here is I've gone through and I've renamed a couple different things. Right? So now for each can be called to go for each people, right? So go through all the people, and for each one of them, announce the person. And when I run this right now, for each one of the people, there's an announcement. Sorry, man. For each one of the people, there's an announcement. I can do the same thing for each of the people. There is a leaving person. Now for each, there is a leaving. And you know what is fantastic about this function? Is that this for each function does not even have to depend on people. I could say for each 1, 2, 3, 4. And then I could write some extra functionality here. So this is saying for each element of this array, maybe what I want to do with every element is I want to console.log element times 100. And I've been able to write some like profoundly expressive code, right? By leveraging the fact that like I have this for each function. When I run this right now, and I'm going to comment out these two up here. When I run this right now, what do I get? Every element times 100. And I run this now, and I get 100, 200, 300, 400. Because again, I've made my for each function very generic. Right? Now, I know that I went quickly through this last part. Right? And the reason I went quickly through it is, one, it's filmed, so you can watch it over and over again. Second, we're getting close to the end of the lecture. But third, this is very much the kind of thing that you're just going to be doing over and over and over again with your assignments today. Right? Is you're going to be taking stuff and making generic functions that can take customized functionality. So this function here, for each, does not even have anything to do with people. And does this idea, does this seem exciting as a programmer? Right? Do all kinds of funky stuff. All kinds. Now, I said that I was going to end the lecture with a little bit of vocabulary. Right? I'm going to end with a little bit of vocabulary and with one fun syntax thing. The vocabulary is this. This kind of function here, this function takes a callback. Takes a callback, and I might even rephrase it. It takes a function, right, and then calls it. Right? So it's a callback pattern. This kind of function here that implements this pattern, it has a special kind of name. Right? What was your name again? Camilla. What was the name of this kind of function? Yeah, it's a higher order function, right? This is what a higher order function is. A higher order function is a function that receives another function. Right? It's a function that's very generic and depends on extra functionality being passed in. Notice that for each on its own, useless, unless you give it a callback. It's useless. It doesn't do anything. It just loops. But it doesn't actually do anything. Right? So that's some vocabulary that I wanted us to be exposed to. But if people say higher order function, it's a function that takes a callback. Right? And then the last thing that I wanted to show you was this. You probably have already seen this. I think it's in the prep course, but since we're a couple days in, sometimes people forget. I had said that some parts of a function are not necessary, such as the word function. Not very necessary. Instead, I can get rid of the word function and use a little chubby arrow. Right? It's called a fat arrow. That's it. That's what I wanted to show you. This is called an arrow function. Arrow functions can get a little bit funkier than this. I want you to take some time to maybe look up a video or an article on arrow functions. But if there's one thing that I can impart on you, this is it. The switch from this to this is technically all you need to know for arrow functions. Right? And the rest is extra. Cool? Yep.
Just curious, so in general, when you, let's say, work on an assignment, and you want to design a function, you decided to take a callback because you have a set of data and you want to do various things with the data, but you don't know what it is just yet.
It might be for reasons like that. Maybe if you're making, let's say, my general rule for why we would use a callback, right, is when I have a function that's generic and it depends on more functionality, right? So again, here, I'm looping through stuff, but I'm looping through stuff for a specific purpose. There's the loop, and then there's the announcement. Or there's the loop, and there's the multiply by 100, right? So where they have some common thing and then some extra stuff, you can take that extra stuff and pull it out, right? And inside of your higher order function, you just say, here is the placeholder, right? That's the general pattern. So in the assignments, they'll guide you through when to use it in these first couple of days. And then over time, you'll start kind of discovering the stuff. Now, I have to say, I've pretty much exhausted what we can kind of talk about callbacks-wise without making you do a bunch of work, right? There's way more to talk about with callbacks. The callbacks are very useful, but until you've played around with them a bunch and until you've run into specific problems, there's actually really nothing more that I can say. look forward to the fact though that on Monday and over the course of like the next couple weeks really, you'll be discovering brand new reasons to use callbacks. But again, you have to run into those problems first. Okay. Good? Did you find this stuff useful today? Cool. There are notes that are going to be sent out very soon. Give me like 10 minutes, maybe a little bit more, maybe 15. I'm going to format the notes that I wrote up today. But what I'm going to do is like I already have some notes that are written. Like I already have some pre-written notes. These ones here are going to stay in sort of like a raw format, and I'll paste them at the bottom of my pre-written notes. Right? So you can scroll down to see the stuff that we wrote today. And then I'll also have a GitHub repo with all the code that we wrote. Cool? Message me on Slack if you have any questions. My name is Nima, N-I-M-A. Cool. Any questions before we close? Dope. Again, you can always message me. Thanks, y'all, and have a great rest of the day. Hey.
Just a quick question. So for the callback function, you don't need to have a return.
No. So if you had a return, it would work the same way as like a usual return would. So I wanted to show you that like return isn't actually part of callback functions. The reason I might want to maybe use a return is, and this is extra, but say that this for each was supposed to give me a new array. Okay, so imagine that, like if for each was supposed to like actually give me an array. So I go through this one, and what I want to get back is an array that looks like 100, 200, 300, and 400.
Yeah.
Right? Then I would need to do something with this. First of all, for each would need to return to me some new numbers. Right? And we could see what happens when I like console.log new numbers. I'm going to find right now, when I run this, I get undefined. Right? At the moment this is undefined. Because for each needs to return something for me. So what I can do is I could go into my for each, and I could go, okay, well, return maybe an empty array. Right? And right now, when I do that, it comes back as an empty array. Right? Now, what I might want to mess around with is maybe start off with const new array, start off as empty, and then maybe for each one of these, I could, and this is not going to be correct yet, but like I could go new array dot push the element, right? And if I was to then go return the new array, then what I get back is all of the original elements. But if I was to say, don't push the element, but rather push the transformed element, right? So we'll go const new element, right? Then I could say, okay, well, new array push the new element, right? When I run this right now, what I get is a bunch of undefines, right? And the reason I get a bunch of undefines is because I have to look at the return value of the callback. So see, I'm saying, take the return value of the callback and put it in a variable and then push it. So let's go see what the callback is. And we go to the callback. What is the return value of this?
There's no return value.
Exactly.
Just print out.
So I could go return element times 100, right? And now what my thing does is it returns back that. So return is something that like is absolutely useful, right? It's not core to the idea of callbacks, right? But if I wanted to get a value back from it, then yeah, I would have to use returns and chain this stuff together. Notice the way I worked through it was like working backwards. It's saying like, this is where I wanted the value to be, so I had to go into for each and add a return statement, and then I had to go into that and add, right? So there's some steps. That's a great question, and I think what I'm going to do is I'm going to take this, I'm going to make it its own file that you can take a look at to like compare the two. So
like you mean like for the callback function, the return doesn't like necessary.
no, so the callback pattern it does not have to do with return.
Okay.
What the callback pattern has to do with is it has to do with one function calling another function that was passed in.
Okay.
So So here, I'll call this this new file callbacks with returns, and you can take a look at this one and see what the difference between the two of them is. I'll take out the parts that aren't needed though. Cool. Don't stress out too much about this right now though. Like you'll work your way up to this.
Sure.
Returns are like they're an extra layer. As long as you understand this one, right, and it sounds like you understand this one.
Yes, I
right?
understand this one.
Then you understand callbacks, right?
Okay.
And everything else is extra kind of layers that get added on top. Then you can take time to add those layers.
I'm a little bit confused about here. Like I know it's callback, but element like this. So like I mean that put the element.
So I did call this oh whoops, sorry, 1 sec. Okay, yeah, I did call this element, but you can call this anything. You can call this thing and thing. Right, so this is one function, and that is another function. I wrote this as an arrow function just at the end to be like, but see, so this is like an inline function that's declared somewhere. If I wanted to, I could maybe put this somewhere else, and I could go, okay, well, yeah, I'm just gonna. I could put this somewhere else, and I could say, okay, function. This is multiply by 100, right? And then this would be multiply 100. Right? So it doesn't need to be written in line.
Okay, so so for this one I'm calling for each function, and I put like an array into the function, and I put also like put the multi 100 function as a callback function.
Yeah, that's perfect.
Oh, it's a little bit weird.
Yeah.
Yeah, like.
You have to like twist kind of the way you're
twist.
thinking,
Yes.
and then it gets to a point where it clicks, and you really think in that way, kind of nonstop. Right? But it does take a little while to get into that. So don't worry if it like doesn't immediately make sense. Although apparently it looks like it's making sense to you right now.
And my question is like for this thing, what's this?
So this could be some like anything.
Oh yeah, anything. Like
This is a
just
a function that takes something.
something.
So say if I went mult 100 for like 78 right now, and we just look at those lines of code.
Okay. Yes. Yeah. Okay. I put 78 into this and times. Like,
Exactly.
turns out times
Right. So when I
100.
do it this way here, right, imagine that this said multiply 100, right? But instead of writing it there, we pass it in, and that replaces that. So that for each can be many different things. It could be for each one of them announce person, leaving person, or multiply 100.
Okay.
There you go. Yeah.
Okay. So the process is that this is the function, and this function uses this function as a callback function. Here is a callback function, and should I put this element back in the
There you go. Yeah.
first function? Oh, so what I didn't really understand is that this like what's this like? I didn't really understand. So actually I put this in the function that I was called back.
So this here is going to be each one of these elements.
Yes.
Oh,
I now understand that.
Yeah. You're going to go through a lot of cycles.
Yes.
I find that I get really close to. It's kind of like have you ever seen like marbles in a funnel before? Have you ever like seen anything like this before, where they like, you go, this is what my understanding is like. Like I get really close, and then I get further away.
Yeah, further. Yes,
Yeah.
that's one. Sometimes I'm.
But eventually, like you're getting closer and closer every time.
Oh.
Right, so, yeah, this is
Okay.
this is 100% what learning is.
Okay, thank you.
Yeah, no problem.